Hello, my dear students. Let us discuss about next topic, elementary profile of a gravity dam. You can see here, this is a elementary profile of a gravity dam. Pressure is zero here and is maximum at the bottom, that is at the base. It means cross section of dam which is designed for the maximum height of dam above rock foundation. It is imaginary section having right angle shape. You can see here, this is a right angle shape. Water phase is vertical here. Water phase is vertical. Then, in the absence of any force other than the forces due to water, an elementary profile will be triangular in section. You can see here, this is triangular in section having zero width at the water level and where water pressure is zero and a maximum base width B where the maximum water pressure acts. Okay, here pressure will be zero at the water level for zero width and the pressure will be maximum here, that is at the base with B. Thus, the section of an elementary profile is of the same shape as the hydrostatic pressure distribution diagram. This is a pressure distribution diagram. Here it is 0 and it goes on increasing here, and this side it is maximum. For reservoir empty condition, a right angle triangular profile as shown in figure will provide the maximum possible stabilizing force against overturning without causing tension in the base. This is so because the weight of the dam acts at distance V/3 from the upstream face and is close to it. If any triangular profile other than the right angled one is provided, its weight will act still closer to the upstream face to provide a higher stabilizing force, but tension will be developed at the toe when the dam is empty. There are main three forces: weight of the dam, water pressure, and uplift pressure acting on the elementary profile of a gravity dam. That is given by here, weight of the dam is given by pH gamma C divided by 2 and pH, that is water pressure, that is equal to gamma WH square divided by 2 and uplift pressure PU is equal to C BH into gamma W divided by 2, where C is uplift pressure intensity factor. Okay, this is about elementary profile of a dam. Here, this is an imaginary section and is triangular in a section and right angle, and mainly three forces are acting here: weight of the dam, water pressure, and uplift pressure. Okay, next let us see the next topic, that is general design criteria. These are some of the general conditions you should know before constructing any type of dam. That is, first one is local condition, availability of public facilities or utilities such as water supply, sewage disposal, electric power for construction purposes, telephone service, construction camp, and need for permanent buildings for operating personnel should be well available. Maps and photographs. A map should show existing towns, highways, roads, railroads, and shipping points. Ground and aerial photographs and general area map should be obtained, locating the general area within the state together with country and township lines. So the maps and photographs also needed. Hydrological data, stream flow records, stream flow and reservoir yield, flood studies, sedimentation and water quality studies, groundwater conditions are to be collected. Reservoir capacity, a topographic map of the reservoir site is to be collected. Annual periodic fluctuations of reservoir levels, area capacity curves for storage of the spillway, design flood are to be calculated. And also climatic effects, weather service records of mean monthly air temperatures, river water temperatures at various times, wind velocities, and prevailing direction, amount and annual variance in rainfall are to be collected. So these five are the main important criteria for the design of any type of the dam. The first one is local condition, second one is maps and photographs, third one is hydrological data, and the fourth one is reservoir capacity, and fifth is the climatic effects. Okay, now let us discuss about common causes of failures of dam structures. The most common reason behind the failure of dam structure is overtopping. Overtopping is a major failure that is created due to heavy floods. There are two main factors that cause the overtopping failure. One is the continuous flow that is created due to surface elevation that will exceed the complete structural elevation profile. And the second main reason is the overwash from the waves, where the surface of the water stays below the structure elevation profile. Okay, so there are mainly two factors which cause the overtopping of the failure. The first one is continuous flow that is created due to surface elevation, and that will exceed the complete structural elevation profile. And second one is the overwash from the waves, where the surface of the water stays below the structure elevation profile. Most of the embankment dams does not have much withstanding power towards the overtopping effect. But the concrete dams will withstand this to certain level as they have strong rock foundation. Okay, this is most common in earthen dams or embankment dams or earth dams, because they doesn't have much withstanding capacity towards the overtapping effect. But the concrete dams, like gravity dams, they can withstand this withstand against the overtopping to a certain level, because they are constructed of a strong rock foundation. In addition to this overtopping, there are many other causes of dam failures. That is, the one is the foundation of the dam is inadequate. Suppose the foundation of the dam is not proper, inadequate, then there may be a failure of the dam. And also piping causes erosion of the foundation, and subsidence and the movement of the foundation, and uplift from the ground and sliding of the structure, then variation in temperature unequally throughout the dam structure, then water bridging issues, then dynamite blasting in the nearby areas causing vibration to the dam structure, seismic load action, then wave action on the structure, and weak energy absorption characteristics of the structure, then higher amount of silting causing greater loads that expected during the design of the dam, then concrete and nearby rock or the soil surface losing shear capacity. So these are the some of the other causes of the failure of the dams. Okay, so these cause of failure may be classified as hydraulic failures, or this is common for all type of the dams, and also the failure due to seepage. So these are the main two types of failures. The first one is a hydraulic failure. This is common for all type of the dam, and second one is failure due to seepage. There are again two types through foundation, all except arch dam. This can be observed in all type of the dam except the arch dams, and also through body of the dam. This is mainly in embankment dams or earth dams. Okay, so dam failures are most likely to happen for one of the following reasons. That may be a slope stability failures, piping failures, overtopping failures, foundation failures. Already I have told, but we'll see in detail what is this failures. Okay, how it causes or the failure of the dam happens because of these types of these reasons. Okay, slope stability failure. If the driving force is greater than the resisting force, the soil mass will slide along the slip surface and a slope stability failure will occur. Then the potential for failure for a given soil mass is quantified in terms of the factor of safety, which is defined as the resisting force divided by the driving force. Okay. Then also due to there are three types of slope stability failures: steady state and seismic, and also the rapid drawdown. Liquefaction can occur during an earthquake in loose saturated sandy soils. Foundation defects, including settlement and slope instability, cause about 30% of the dam failures. Okay, so these are some of the common reasons of slope stability failure. The first one is driving force is greater than the resisting force, so soil mass may slide along the slip surface and slope stability failure occurs. And also the potential for a failure for the given soil mass is usually quantified in terms of factor of safety. And there are three types of slope stability failure: steady state, seismic, and rapid drawdown. And also liquefaction can occur during the earthquake in loose saturated sandy soil. Liquefaction means the soil behaves like a liquid. It loses its shear strength properties. So, foundation defects can also causes the slope stability failure, including that stability, settlement, and slope instability. Around 30% of the failures are used to happen due to this type of failure. Okay. Next, the second one is the piping failures. The cavities and cracks can act as preferential conduits for water to flow freely through the dam and erode the dam from the inside out. This phenomena are referred to as piping. This is mainly due to the formation of the cavities and cracks in the soil. So this leads to the piping failure. And also the cracks and fissures, high permeability strata, and the karst features in the foundation and abutments may also act as preferential conduits and contribute to piping. Okay, so the cracks or fissures and some high permeability strata means it allows the water to flow through it. Karst features in the foundation and abutments also causes the piping. Then it happens when seepage through a dam is not properly filtered, and soil particles continue to progress and form sinkholes in the dam. 20% of the US dam failures have been caused by piping, internal erosion caused by seepage. Okay, so this is about piping failures. Next one is overtopping failure. Dams are designed with the principal and emergency spillways to control the maximum reservoir elevation and prevent the reservoir from flowing over the top of the dam or overtopping. So it is nothing but the water flows over the top of the dam. That is overtopping failure. Already I discussed this, mainly due to the heavy floods. Okay, it is caused by water spilling over the top of the dam, and overtopping of a dam is often a precursor of a dam failure. National statistics show that overtopping due to inadequate spillway design, debris, blockage of spillways, or settlement of the dam crest amount for approximately 30% of all the dam failures. Next one is the foundation failures. If the foundation consists of weak materials such as soft clay, a foundation stability failure can occur, leading to a significant deformation of the embankment. Piping within the seam may also be a contributing factor. liquefaction of granular soils during an earthquake may reduce the stability of the foundation. Okay, so these are the some of the common reasons for foundation failures. That is, maybe the foundation consists of weak materials, soft clay, etc. And piping within the seam may also contributing factor, and liquefaction of granular soils during earthquake may reduce the stability of the foundation. So these are the some of the common reasons for the failure of the dam. I hope all of you understood. Thank you.